right, ladies and gentlemen, we're looking at the paper folding activity and correcting and making sure we have the same answers. We already had this filled out. If there's 0 folds, there's 1 section. 1 fold, there's 2. 2, there's 4. 4, there's 8. 4, 16, 32, and 64. We know what's happening each time. It's getting bigger, and it's getting bigger by how much? So it's, what do we call that? Doubling. It's doubling each time. Okay, so this is going to disappear because I am going to close this. Okay, so here is our graph for those numbers. At 0, we're at 1. At 1, we're at 2, and so on. Okay, it's off the charts. It's up at 64. All right, so we know it's doubling. We know it's exponential. Therefore, we know that the equation is y equals 2 to the x, or 1 times 2 to the x. If you put it in your graphing calculator and chose to do an exponential regression, it would give you this as your equation. But we know from doing it, doubling means you're taking it to the second power. So if we stuck in 4, 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 folds, 16 sections. Okay. The next one, we want to know the area of the section. If we have 0 folds, we have 1 section. If we have 1 fold, how big is the section compared to the paper? A half. And then we have a, and then we have a, and then we have a 32nd, and 164. Okay, just from the previous graph and the previous equation, what do you think this equation should be? Okay, remember what we took from last time? We had, this is number 1, 2, 4, 8, 16, 32, 64. How did I know to use 2 for my b value? When I had 1, okay? So, what are we going to use for our b value if the equation is written in y equals ab to the x? We're going to use half, okay? Okay. So if I look at a, how do I figure out a? Well, I can put it in x and a y. Well, if I stick in 0, I get out 1. If I stick in 1, I get out 1/2. If I stick in 2, I get out 1/4. Okay, so a has to be 1. Okay, but anything times 1 is just itself. So you could leave it as y equals 1/2 to the x. All right, and then this is my graph. All right. So ladies and gentlemen, we're now going to look at our rhino activity. Yes, black African rhinos are being endangered because the gray ones aren't endangered as badly as the black ones. Okay, the African black rhino population. All right, this is what we are going to do next. Yes, please. Okay, so some of you have this already and you can pull it out. I believe I gave a couple people it's done yesterday. All right, so the African black rhino is depleting in size. In 1960, it was 100. 1980, it was 15. 1991, there's 3.5. 1992, there's 2.4, and those are in the thousands. Okay? So it's not like 100 total. It's in thousands. Okay? So this is the part that a lot of people got mixed up. Let's look at the bottom of this graph right here. It says timeline in years since 1960. So what would 1960 be? No. What? If 1960, it'd be 0. There we go. Okay? So at 0, we're at 100. So what would we be at 1980? If 1960 is 0, 1980 would be? 10. Okay, so I heard a lot of 10s. 2. So 1960, the next decade is 80? 20. There we go. It's okay, I just want to make sure we get it. 1991 would be what? 40. Let's try that again. 31. Thank you. And 1992 would be? 31 and 32. Okay. So we want to use those numbers instead. So when we put them in our graphing calculator in our list mode, we want to make sure we put those numbers, not 1960, 1980. Okay? Here's another thing we want to talk about. We're going to, once we come up with our graph, we graphed it on a paper, we put it in our calculator, we found out our equation. We want to stick certain numbers in for x. What numbers do we want to put in? If we want to find out what it's in 1998, do I stick in 1998? No. What do I stick in there? If 1992 is 32, 1998 would be?
27.
38, thank you. And 2004, if the 90s are in the 30s, the 2000s are in the?
40.
And it's 2004, so it would be 40?
4.
There we go. All right, this one is kind of difficult. 1950. 1960 is 0, so 1950 is? Negative 10. Okay? You should be able to do the rest of this on your own. You have plenty of time in class to get this done. Please don't do number 6. Please don't do number 6. I want to put up here how to put it in your calculator. Okay? So, let's put this in our calculator. Our first step is go to New Document. Okay? Then we make sure we're on the one that says Add List. Okay? We choose, we put in X and Y, and then list your table. What do I do next? Does anybody remember? We hit the yellow button and dock, and it gives me a new page. And then I'm going to, this is, if you hit 4, you get the same thing. You're going to hit 5, your Add Data page. Okay? You have to click where it tells you to click to put X and Y. It'll give you little instructions on the screen. Okay, and then you have your pretty dots all up there. Who remembers how to get the regression? Anybody? Yeah, the regression lines that we did yesterday. Menu, 4, 6, and you're going to have to choose. Okay? And we've talked about how you choose. If it's a straight line, you want to choose which regression? Linear. If it is like a U shape, you want to choose what? Okay? And if it either goes down really fast and gets close to 0 but doesn't go back up, or goes up really fast but doesn't have the U shape, what do we call that one? Exponential. Okay, so you're going to look at the graph and decide which one you choose. Okay? That's going to give you your model. Then you can answer the rest of the questions. I also have a homework assignment for you tonight, the crickets one. Okay? And that one you don't need a graphing calculator to do.